Welcome to the last and final session of the summit. Hope you guys all have had fun so far. My name is Michael Arnold. I will be talking about what it's like to run a non-Yahoo sized cluster, which I'm guessing most of you would be interested in. Something in the much smaller, manageable range. So I'm going to go over the who in the world am I, who's this Apollo group, define a couple of terms, make sure we're all on the same page, go over some decisions that you're going to want to make right now at the beginning, assuming that you haven't set up a cluster yet, or if you've just barely started, and some decisions for later on that you can put off, and then go over some lessons that we've learned in the 2 and some odd years that we've been running our small cluster. So first off, the who. Apollo Group is in the education business. You probably best know us as the University of Phoenix, as well as several other subsidiaries that we have, online schools and such. We are an international company with schools in Chile, Mexico, and Great Britain, as well as Canada with Western International University. Myself, I am a systems administrator. I've been doing Unixy type stuff for about 13 years or so. I'm into automation. I really hate doing things more than twice. So if I can, I'm going to figure out how to make the robots do my job for me. I deal with hardware specifications, firmware configurations, OS, all the way up to Hadoop application, and monitoring all of those things as well. And a couple of definitions. So what is this tiny, small, medium, large? Just so that we have a baseline to compare what we're talking about. Just some numbers I've pulled up. I'm not the canonical source for this. Just want to make sure that we're kind of in the ballpark with what we're talking about. Anybody here have a Yahoo-sized cluster? No. Well, maybe one gentleman. Okay. We're mainly in the small area, so that's where I'm focusing. That's my experience. What is a head node? Head node is going to be the master node, a node that runs one of these very important processes, the name node, job tracker, secondary name node, zookeeper, or HBase master. They're kind of in the important category. Everything else is going to be a data node task tracker. So with that, what sort of decisions should you be concentrating on now? And we'll go over the ones that we can postpone right after this section. So first question that you need to answer, which Hadoop distribution should you use? There are quite a few. I'm not going to tell you which one to use because your choice depends upon your business requirements, whether or not you're into purely open source, whether or not you want a support contract with a vendor, whether or not you want some advanced features that some of these vendors offer. So you're going to have a little bit of reading to do, and I'm sure if you've been over in the common area, you've talked with some of these vendors, and you might have a good idea of it at this point, what they offer, what their differentiations are. So that's the first thing you got to pick, because it's hard to run Hadoop without Hadoop software. Next question is, should you virtualize? If you're starting off small, it's okay to do virtualization. It does add overhead. There have been some of the tracks here at the conference about how little overhead there really is. Maybe a little bit of performance degradation. And you definitely can't take advantage of the rack locality in general, although there is seemingly some work being done in those areas. But virtualization really is good for doing functional testing. If you can get a small data set in there, have your developers work on it and get the code running, then you can translate that into your larger clusters running on possibly physical hardware. Good for testing your workflow changes as well. And for evaluating your Hadoop software upgrades, it's great. Spin up a virtual cluster, install your current version, make sure the configs match your production, and then go through your upgrade process. If it breaks, no worries. Just reboot everything, reinstall, and go from there, and you're not really impacting your production cluster. You don't have to buy hardware and have it sit out there or otherwise idle in a little test cluster for your sysadmins. So those are some good things that virtualization can be used for. Going the physical hardware route, what type of hardware should you be considering? Top of the list, inexpensive stuff. Because eventually you're probably going to want to scale up into the medium-sized cluster. And after a while, things start adding up. You go from a 10-node cluster to a 100-node cluster, add a 0 to that amount of money that you're spending on your hardware. For most of your nodes, you don't want enterprise-y class hardware. You don't need RAID. You don't need redundant power supplies or those sorts of things. If you can, keep an eye out for low power consumption. Eventually, if you do scale, your power budget will come into glaring contrast to everything else that might be in your data center, and folks will start asking you to turn down the power usage a little bit. So just think about that up front. Optical drives, you probably don't need them because you're going to want to boot off the network and try and automate your OS builds. If you need optical drives, go buy some USB CD-ROM drives or whatnot and plug them in for your first dozen nodes or so. When you are racking and stacking, try and plan ahead for capacity expansion. If you've got a cabinet that you can dedicate to Hadoop, start installing your machines at the bottom, leave some space for expansion. Put your switch in the middle so that you only have one length of cable between the top and the bottom of your cabinet. And as best you can, leave some room for adding machines later on. Going a little bit further, try and get 2 cabinets if you can. This way you can split your cluster. You can start doing redundancy at the rack layer in case you have one cabinet go down due to power or maintenance or whatnot. You can still run your cluster on the second half of the nodes that you have. Separate out your head nodes between those 2 clusters, buy 2 switches, and kind of scale up from there. And if you're worried about that upper half of the cabinet going to waste and having to reserve it for Hadoop, well, you can just install another cluster up there and utilize the space in that manner. So those are the decisions that you kind of got to start off with. Once you answer those particular bits, you can start thinking about other things that you can change a lot easier. One of those things is what size of a cluster should you have? Well, this is going to depend a lot on how much money you have to spend, what size data you're dealing with, the kind of characteristics of your workload, which if you don't have a Hadoop cluster, you probably don't have an idea of what your workload is going to look like. Is it going to be CPU bound or IO bound or those sorts of things? So you can wait until you have a little bit of data with testing to determine that. And what sort of SLA are your jobs going to be needing to meet? If you need to have things be processed faster, you're probably going to want to buy more nodes to add to your cluster so that you have more CPU to throw at your problems, that sort of thing. You're also going to have to consider what your MapReduce jobs are doing. Are they going to be compute intensive? And this goes to the workload question. Are they going to be reading lots of data? These 2 things depend on, they make you buy either more CPUs or more hard disks or some sort of in-between version of those. Cloudera's got a good blog post about the various tunings and types that you can deal with depending on your workload, different hardware configurations and such. Another thing that you can put off toward, another question to answer a little bit later on is whether or not you should implement rack awareness. And if you have more than 2 switches in your cluster, you definitely want to do this. It sort of tells Hadoop what your network layout is. If you have 6 nodes attached to one switch, 6 nodes attached to the other, they're going to be able to talk amongst themselves on that switch and have a lot more bandwidth than your connection between the switches. And that's what rack awareness helps you out with. It tells Hadoop that, hey, the nodes over here in this cabinet and attached to that switch have a lot more bandwidth between them, and do some optimizations for that versus going across that inter-switch link. Should you use automation? If you don't have any sort of build automation, configuration management at the beginning, well, that's okay. You can always install everything manually and learn the ropes, but I definitely recommend that you get your OS automations and whatnot in place as soon as you can. Hard drives are going to fail. Sitting out there with a CD-ROM and clicking next and answering questions manually gets old after a little while. So make sure you get your OS deployment automated. It saves time. It does reduce errors because eventually you're going to forget a step and you're going to have one node that's a little bit misconfigured and weird things will start happening on your cluster. There's tools out there in the open source space to use. If your shop has particular tendencies to lean towards one or the other, just use something to automate your builds. And that's the sections on questions and things to answer. Now we're going to go into some lessons that we've learned at Apollo with our 2.5 years worth of experience. First thing we learned is keep it simple. Hadoop has a lot of smart stuff built into it. It can deal with failures. Don't try and over-engineer your solutions. You just tend to make things more complicated, and eventually it will impact you in ways that you didn't anticipate. So let Hadoop do the things it's good at. Automate your hardware. And this isn't OS or software automation. This is firmware automation, BIOS configurations, that sort of thing. Sitting there in a data center for 12 hours, bringing up your first cluster of 40 nodes, and going through each machine one by one to make sure that you flip one of the BIOS settings got old pretty quick. Depending on your hardware vendor, there are different toolkits out there for automating all the BIOS and firmware configurations. Take a look into it. It's definitely pays off once you have node replacements start with hardware failures, which if you're using the inexpensive hardware, you will have failures. So make sure you can automate your hardware as well. Rolling upgrades are possible, just not of the Hadoop software right now. You might have heard about the new Hadoop 2.0 stuff with wire compatibility, and they'll be able to do rolling upgrades. But right now, everything else you can do. You can decommission your node, which will move all your data blocks off. It'll stop executing tasks on that node. Once it's decommissioned, you can go ahead and patch it. You can even rebuild the whole thing, add it back into your cluster, and your cluster service is still up and running, but you're managing to get your data nodes rebuilt or patched or whatnot. Small things can have a big impact on your cluster. We had an instance recently with a single bad NIC, it turned out. It happened to be on our name node. We were actually using NIC bonding, so active-passive, for our name node, just in case a switch goes down or whatnot. The problem being that the switch port started doing strange things. We were able to do TCP connections on our name node, but ICMP echoes weren't happening. And this caused slowness in the jobs as they were executing. Our name node is also our job tracker. So we were tailing the logs trying to determine what was going on, and we'd see spurts of activity and then pauses for a good 2 minutes or so, and then more activity. And tracing it down, it was just a single bad NIC. We failed that bond over to the B-side network, and things started running just fine. So little things, you've got to watch out for them. Another thing we've seen is that slow disks can cause job slowness. Your disk might be running at 100 megabit each. You might have 6 disks in a node. But if one of those disks is running at 20 megabit or whatnot, a large job that's trying to read and write one of its task data to that particular disk, that's going to be running a lot slower than the 30 or so other tasks running on all the other nodes. So the entire job will end up waiting for just the data coming off of that one task on that one slow disk. So keep an eye out for those sorts of things. If you have the right instrumentation and logging and monitoring, you can catch some of this stuff. Some of it can be just by chance at times, but keep an eye out for those. Another thing we learned, HDFS blocks are kind of weird. On your ext3 or 4 file system on your Linux node, that's where HDFS throws its blocks. And I was under the impression long ago with HDFS's block size being default 64 meg and recommended 128 meg, that all those files that are written into HDFS show up on my ext file system as 128 meg. And that a 5 megabyte file written into HDFS, well, it would be 128 megabytes, but it isn't. It's actually the size of that file, which was a little strange for me to see. But eventually I figured out, along with the next point, that metadata is actually in a separate file from that block on the ext file system. So each block is 2 files. Why is this important? Well, I kind of prematurely optimized things. I figured all my files are going to be 128 megabytes, so let's have less inodes in my ext4 file system. Well, each block being 2 files, I kind of miscalculated. If you ever looked in the etcmeki2fs.conf file, there's a setting called large file 4, which will tune your inodes down to about, I'm not sure of the inode ratio exactly, but let's say on a 1 terabyte file system, you have about 60,000 inodes, which with 2 files per HDFS block is about 30,000 files, which at 128 meg, you can't even fill up your 1 terabyte file system. We ended up running out of inodes long before we ran out of space. And that caused us to have to rebuild our cluster. I have an example here of the tuning we're using today, 131.072. I don't recommend just taking that and using it. It was a good trade-off for what we were tuning it for. We've got about 7 million inodes now on a 1 terabyte file system. And that seems to be plenty for what we're ending up doing at this point. But do a little testing and read into that, or just take the defaults. Use DNS-friendly names for your services. And this will help out your end users and folks that have to put in URLs and pointers to the various services that MapReduce and HDFS and whatnot have running on your cluster. These examples, the names are kind of long, but if I told you to go talk to the Uzi for Bravo cluster, I bet you could figure out exactly what to put in your browser. So think of a good scheme for your users and help them out instead of giving them possibly cryptic node names for your services and where they're running. And it'll also help that it'll help you to move your services without having to go into all the applications that are talking to your cluster and put in a different URL for your HDFS name node. Use a parallel remote execution tool. I mean, if you have to do SSH in a for loop and you're comfortable with that, that's great. Func and mcollective are some pretty awesome tools that will allow you to go out and run a DF across all the nodes in your cluster or across just your data nodes, or however you decide to configure it. So if you're ad hoc, one-off commands that your configuration management tool wouldn't be running, definitely use something remote and don't try to SSH into each of your nodes and run the command and then log out and log in somewhere else. Try and run it from a centralized location. Make your log directories as large as you can, because eventually your developers are going to run jobs with debug set on that are going to output 1 line per row of a billion row table, and your logging directory is going to fill up, and your job's probably going to fail. So give those log directories as much space as you can, and definitely implement cron jobs to purge those directories. I even heard somebody else mention in one of the courses compress those logs if they haven't been read in a day or two and whatnot. So definitely keep track of your space from that perspective. And also be careful of your temp file system because MapReduce jobs can, if they're written in a particular way, they can write temporary files out there and fill up your root file system as well. Make sure you've got IPMI 2.0 preferably for your out-of-band management of your hardware. Everybody's heard of ILO and DRAC and RSA and the various things, but make sure you've got IPMI support on your hardware if at all possible. It helps out with standardizing the configs or how you interact with that. You don't have to have a browser with the right version of Java to pop up your console anymore. You can simply use command line tools and get on your serial console remotely, and it just makes life pretty simple. You get standardized hardware temperature monitoring. You don't have to install funny tools running on your OS anymore to keep track of those sorts of things. And it gives you good command line remote power control. You can power cycle, turn things on and off quite easily. Spanning tree is the devil. I spent quite a lot of time in our data center trying to figure out why my BMC cannot get a DHCP address. And that's because, well, I'm not a networking guy, but I quickly learned that spanning tree is quite required on switches. But you do need port fast enabled because for the first 60 seconds when a NIC comes up, those switches want to make sure that they're not talking to another switch and causing some sort of routing loop. Which, of course, when you're trying to get your BMC to get an IP address, it tends to time out long before that switch port starts passing traffic. So if you're not the networking guy, if you've got a networking team, make sure they turn on port fast or whatever your vendor calls that particular feature. Or you will spend many hours trying to figure out how to get an IP address on things. Apollo has rebuilt our clusters at least 4 times, and you might as well, or you may end up doing so. It's not horrible if you keep your options open. Hopefully some of this stuff is a learning experience and you can not fall down the same holes that we have, but you might end up doing it. A short timeline of our builds. Our very first cluster was a whole 4 nodes. We ended up having to go get a USB CD-ROM because our build automation wasn't ready. But we got CDH running up on our very first cluster in a few hours. Our second build, however, we did sit down and do our automation. We got our OSS building. We used Cobbler. It has a nice templating engine and whatnot. And we got all of our machines built, and they were standard builds. All of our Hadoop software install and monitoring and whatnot was done in that Kickstart file. So we didn't have continuous management of the install after that point. But it was a step. We learned, and we kept improving. Our third build was when we realized that our logging directories weren't quite the size we needed, and expanding your root file system isn't quite the thing you want to do on the fly. So we decided let's rebuild the cluster node by node. Most of our deployment was still in our Kickstart. And our most recent build, this is when we discovered that inode tuning is something not to be taken lightly. But we managed to get our full Puppet automation. The Kickstart was mainly the OS and bootstrapping our Puppet agent, and then everything else was Puppet automated installation and maintenance after that. In terms of failures, this is the most common stuff that we've seen in our cluster. Hard drives tend to go the most, especially when you're dealing with the low-end SATA drives. We kind of planned for it, so instead of spending twice the amount of money on a disk, we accept that there were failures, and it hasn't really caused a cluster outage. That's the most common thing to go. We've had disk cabling problems. We don't have fancy backplanes and hot swap drives in our particular model of machines, so sometimes those SATA cables were just a little loose or not quite connected, and we'd have to bring the node back down and fix it. We've had 2 RAM failures in the 2.5 years running, and one switch port, it seems so far, that's gone bad on us. Software-wise, the only thing that's really brought down our cluster was the NFS export that we have between our secondary name node and our name node. We use this configuration to store one of the copies of the metadata from the name node. And so when that NFS export becomes unavailable, the name node gets a little cranky at times, and sometimes it'll just die off, and that pretty much turns your cluster into a lot of hot air that's being blown. Job-wise, we have task tracker Java heap errors. Turns out to be a bug in our CDH version, so we're planning an upgrade to solve that. Running out of temp space or log space tends to kill off jobs. So we've got good monitoring on that, but sometimes a job can output 20 gig of data, and there's not a whole lot you can do about it in 5 minutes or so that it's running. And running out of HDFS space can cause fun stuff to happen with failure. The most important thing, I hope, to pass on is that you should know your workload. All the rest of the stuff that you can do with your cluster configuration is just magical hand-waving if you don't understand what it is your jobs are doing. If you have that understanding, you can tune properly at the hardware level, at the software level, and get the most performance out of your cluster that you possibly can. So with that, anybody have any questions for me? If you do, please come up to the microphone up here in the front. And if you don't, have a wonderful time. Yep. One question from the gentleman.
You talked twice about characterizing your workload. How are you doing that?
So I have some awesome software developers that understand how all their stuff is working. And I sit down and ask them, okay, are we using more CPU for this particular workload, this job type? Do you need more memory for your jobs? Do you need more I/O, more disks? And they help me as a sysadmin understand how all that stuff is working to try and figure out what to do on the hardware platform.
Okay. How often do you patch?
Right now, we are working on that. A patching strategy. It's a little convoluted having all the interdependencies with your Hadoop nodes, so it's on the to-do list at this point.
Okay, thanks.
Hi there, great talk. I wanted to know the 4 times that you had to rebuild your clusters. How did you manage the data that was sitting in those clusters, the production data?
So for most of it, we did a rolling rebuild. So we'd decommission a data node. That moves all the blocks off onto other data nodes so that your replication factor stays up. And then we'd rebuild that node on the cluster, put it back into the cluster, start decommissioning the next node, and do basically a rolling rebuild that way. When you come up to the head nodes, the name node job tracker, we did have to schedule downtime for that. Downtime was a whole lot less than having to rebuild 40 nodes all at once, so it helped out with that rolling upgrade cycle.
Just now you mentioned hardware failure and software failure. We can see the hardware failure number, and how much is about the software failure?
So at the bottom of that slide, there was some of the software failures that we've seen, mostly caused by the network outage for the NFS layer that ended up bringing the cluster services down. Most of it is a bug that we're seeing with Java heap on the task trackers. They'll basically just go out of memory and die. But in terms of job failures themselves, that tends to be on our development side, and those folks keep track of that. Not sure if that answered your question, though.
No, my question is, I want to know, is the software failure happens often or the hardware failure happens often?
With the task tracker bug, we get a lot more task tracker death than we do failed hard disks. Task trackers in our 40 node cluster, they go out every week. But with our Puppet automation, it tends to restart the task tracker before we get in there to look at it.
Okay, thank you. And second question is, I noticed that for your third build up the cluster, you use the Chef, and for the fourth, you use a Puppet. So why you change the tool, and do you have some comparison between these two tool sets?
So we use Cobbler for the OS builds. We don't actually use Chef. We use straight Puppet for the application installs and configuration management. Right.
How big is sysadmin team you had from starting and when you reached at the mature state of your cluster?
From the beginning, we had myself for the first 2 years, most of that time in a non-dedicated fashion. It wasn't until last August that I actually was dedicated to Hadoop administration. And then last November, we added another team member, Mr. Anau, who you're sitting next to. And just last week, we added a third team member to the Hadoop admin team.
You have 40 node cluster?
Correct. So those first 40 nodes, we split into 2 clusters. So we have a 30, a 12, and another 8-node cluster in QA. And we're hoping to grow in the next month or so a few more clusters. Well, all right. You guys have been awesome.